So 3.3, there is no new rules in 3.3. You are using the derivative rules we've talked about up to this point. So any of the functions that you have in 3.3 would either be polynomials, or they might involve e to the x, or they would be products or quotients. So you already have the rules to find the derivative. So there isn't a new type of function that we're introducing in this section. But it's all on some applications of the derivative. So it's important for you to understand that a derivative is an instantaneous rate of change. So anytime you are asked to find an instantaneous rate of change, or even if it just says rate of change, if it doesn't say average in front of it, it's talking about a derivative. So this is talking about some different applications, and the first one is actually the most common. We've already talked about the application. It's the relationship between position, velocity, acceleration with derivatives. So what I have included at the top, because this is not the only application with position, but in general, for any function f of x, the derivative, so dy dx, that's the Leibniz notation. That means f prime of x. It's the first derivative, the derivative of y with respect to x. That can be interpreted as the rate of change of y with respect to x. And rate of change here would be instantaneous. So anytime they want an average rate of change, they have to say average in front of the rate of change. So we're just looking at a few applications, certainly not every application, but I'm trying to pick out more common ones that you might see. And then just in general, some problems that you might see involving rates of change, just so you understand how derivatives apply. But the first example, as I said, ties in with physics. So I just have as a reminder for you that typically they use s to represent the position or the displacement. So if s equals f of t is a position function of a particle that's moving in a straight line, then change in s over change in t represents average velocity over a time period. And the velocity is the first derivative, which we've already talked about. So ds dt would be the Leibniz notation, which is f prime of t. That's the instantaneous velocity, the rate of change of displacement with respect to time. So we're going to look at an example. Some of these, you've already answered questions like this. Others, we have not. Well, we have not in this class. You may have answered them if you are in physics or have been in physics. But in this example, we have the position of a particle is given by this equation, where t is measured in seconds, s is in meters. So to find the velocity, we know we have to find the derivative. So v of t, oh, your desk. Could somebody help her, please? Because you need to, like, hold the desk. Yeah, it just came unscrewed. It happens, unfortunately. They get moved around and it, like, slowly unscrews. I'll deal with it later, it's fine. Thanks, Jade. All right, so velocity is going to be the first derivative, f prime of t. We've talked about that idea already. So given f of t above, what would the velocity function be? Yes. Okay, so that represents the velocity at any time, the velocity function. So then part B is now using the velocity. What is the velocity after 2 seconds, after 4 seconds? And again, what is the velocity? They're asking for instantaneous, not average. So we can just substitute those values in. So velocity after 2 seconds will be -3, thank you. And the units on the velocity would be meters per second. And then velocity after 4 seconds is 9, yep. Okay, those questions we've answered before, not too bad. Not that the other ones are bad questions, but we've answered them before. Okay, so then part C. When is the particle at rest? How do you determine this? So, well, no, stay confident, Danica. Okay. Well, what does it mean if the particle is at rest? The slope is 0, the velocity is 0. So V prime is 0. We have, or not V prime, I'm sorry, V of t, which is F prime is 0. So you do replace, or rather you set the velocity function equal to 0. And you solve for t. Okay, how do you solve this equation? You can factor. Solving a quadratic equation. If you don't like factoring, how can you solve it? Quadratic formula, yes. You could also complete the square if you'd like to complete the square.
Oh, I remember that. That was easy.
Okay, if I factored this, I always see whenever I ask how do you solve this, I see this all the time for the diamond if you like to do that. But before you even do that, you can factor out a 3 or divide everything by 3 in this case. That'll make your factoring easier. And rather, like I said, rather than factoring out, just divide everything by it, because if you divide it on each side, then it's just gone. So I can divide by 3 and get t squared minus 4t plus 3 equals 0. And that makes this factoring easier. So you're multiplying to 3, adding to -4. So whether or not you do this, how does this factor? The factored form would be what? T minus 3, t minus 1. So -1 and -3 if you are one that sets up the diamond problem. And then these would each be set equal to 0, so t would equal 3, or t would equal 1. So it is at the particle is at rest at 2 different times. So it's at rest after 1 second, or at 1 second, and at 3 seconds. All right, and then when is the particle moving forward? That is, when is it moving in the positive direction? When, or how would we determine that from what we know? When what is greater than 0? The velocity, yes. So this, remember, I know I said it above, I didn't draw a lot of attention to it, but the position function is representing a particle moving in a straight line. So if it's moving forward, the velocity is going to be positive. So this means v of t is greater than 0. So you have your velocity function, that was the 3t squared minus 12t plus 9, greater than 0. Now you're solving a quadratic inequality. Now, we already had factored this, so we know where it's equal to 0. So we had already said this was factored to t minus 3, t minus 1. So we know it equals 0 at 3 seconds and at 1 second. How do we know where it's positive? Or do you remember how to solve a quadratic inequality? There's different ways. There's by graphing or algebraically. So you can solve this if it's an inequality. The 3 and the 1 still mean something. So what you can do is set up a number line, if you want to think of it that way, and you put the zeros of the equation on the number line, so the 1 and the 3, and that divides this into 3 intervals. So you have the interval t is less than 1, the interval where t is between 1 and 3, and the interval where t is greater than 3. And you substitute values in from each interval into your inequality to see where your inequality is true, what values of t make your inequality true. So, for example, if I could substitute any number in that's less than 1, so I could use 0, and I just test it into my inequality. So if I substitute 0 into the inequality, I would have 9 is greater than 0. Is that true? That is true. That means values of t less than 1 are true. So we're moving in the positive direction when t is less than 1. And then I could test a value that's in between 1 and 3. You could test 2. We actually already found this value up here. It was -3. So -3 is greater than 0. That's false. So when t is in between 1 and 3, it's not moving forward. It would be moving backward in that case. And then when t is greater than 3, so we could test 4, which we already know that was 9, and 9 is greater than 0, that's true. So it's moving forward, t is less than 1, or when t is greater than 3. And I would even specify this time interval even further. Negative values of t would not make sense, so I would even specify that t would be in between 0 and 1, and then t values greater than 3. So it moves forward the first second, moves backward the second, or from 1 to 3, and then from 3 seconds on, it's moving forward again. So this is where it would be moving forward. Questions on that? Okay. I am actually going to pause. I just want you to not be rushed through your homework quiz. So we're just going to take a pause here and then pick up with it Monday.